So today I will be teaching you how to draw Lewis dot structures or Lewis dot diagrams. So um, to do this, I will be using carbon dioxide or CO2 as an example to teach you. Bear with me here on the little mouse thing. I'm pretty messy with it, but here we go. So the first step in your Lewis dot structure drawing will be to identify the number of valence electrons that are in this entire molecule and that all the atoms combine to have. So let's take a look at carbon. By the way, carbon dioxide consists of one carbon and two oxygen. So one carbon that is in carbon is in group 4, so that will give it 4 valence electrons. And oxygen is in group 2, that will give it, or sorry, not group 2, there's 2 oxygens. Oxygen is in group 6, that will give it 6 valence electrons. Now, since there's 2 oxygens, we will multiply these two together. So we will get 12, and 12 plus 4 equals 16 total valence electrons. So, first we have the 16 total valence electrons. The second step is to put the least electronegative atom in the center of the diagram. So first we have to identify what the central atom is. The central atom, like I said before, is the least electronegative. And if we take a close look at the periodic table, we can see that carbon and oxygen are both on period 2, but carbon is more to the left, so that would give it less electronegative energy. So therefore, carbon is going to be our central atom. And by the way, if you only have 2 atoms in a molecule like this, then there's going to be a central atom. It's just going to be one bond. So the third step is to place the electrons, place the 2 electrons in between 2 atoms to create a chemical bond. So I'm going to put in these oxygen here, these 2 oxygen, and what I'm going to do is find these two valence electrons here. So I'm going to put these 2 here. So this carbon and this oxygen are both sharing these 2 valence electrons. Same with this carbon. Okay, and so now we have them chemically bonded. And the fourth step is to fill in the octet. So to fill in the octet of oxygen here, we see it has 6 valence electrons in its own state. So to fill in the octet, we would need 2 more than its regular state. So I'm going to fill that in with 6 just to make it look normal. Okay, fill the other one in with 6 here. Okay, so now we have the atoms in their original states, and now we want to complete their octet. So we've only used 4, 6, we've only used 12 of our total number of valence electrons here. Sorry. Okay, so so we have 4 valence electrons left, and we want to fill in the octets of oxygen, right? Both oxygen. So I'm going to do that real quick here. And so you may think, oh cool, we're done, because these oxygens have their full octets and the carbon has 4. But wait, no, the carbon needs a full octet. So what we're going to do is take these non-bonded atoms here, or not atoms, sorry, electrons. See these ones on the outside? We're going to bring them in to the inside to share them with the carbon, and these create double bonds with the electrons. So these electrons create double bonds. There we go. So what we have here now is this carbon with a full octet. See, it has 4 on this side, 4 on this side. See, there's that carbon. Okay? And then we have this oxygen on this side with its full octet, because disregard this little scribble out there, because it has 1, 2, 3, 4, and then these 4 over here, adding up to 8, giving that a full octet. Same thing on this side. And so there, as you can see, that's mostly how to draw a Lewis dot diagram. And yeah, you can also draw them like this. These lines here, these represent the same thing that the 4 electrons, or the 4 dots here, do in the middle. They just represent double bonds. So this would be like one line would be a pair of electrons, and then it would be normal on the outside again, like that. And yeah, so to review the steps, number one, we identified how many valence electrons the entire molecule had with all the atoms combined. So carbon dioxide ended up having 16 valence electrons. So that was the first step. Second step, we put the least electronegative atom in the center of the diagram. Like, first we found that. How did we find that? We looked on the periodic table, and carbon was less electronegative because it was more to the left. And let's see what else. Yeah, so we got the carbon in the center, and then we have step 3, where we put these 2 electrons here to bond this carbon with this oxygen, and then the same thing on this side. So that would create a chemical bond. Those 2 electrons with those 2 atoms, those would be sharing those electrons, and it would obviously be creating a chemical bond. And then step 4, we filled in the octets of the oxygen. So we filled in those 6, and it evened out to 16 here. And then, since we didn't have enough to fully go around here, to fully go around the carbon to get its octet, because it only had 4 and it needed 8, we took these electrons from their unshared sides and placed them in between the oxygen and the carbon on both sides to give both sides a double bond, and that satisfied the octets of all 3 atoms in this molecule. And yes, that is about it. So I will see you later, and have a good one.